So this time we're looking at functions and ranges and things like that. So we'll go through it. Again, there's not a lot in this, I don't think. It's more about the terminology and just trying to get through the language. So what values of x cannot be in this domain? So function f is defined on a suitable domain. All it really is saying is what values of x mean your, calculator says no, the thing's broken. So all we have to do for this one is first of all to factorize it. So we're trying to find out. Let's see, I can factorize that as that'll be x take away 4 and x take away 3. Well, that's a plus 2 on top. So I can't factorize it. If I could cancel anything out, that's as simple as I can get it. And the reason I've done that is because I'm trying to look at the two that I've got. The two rules are that you cannot square root a negative. That doesn't work. And you cannot divide by 0. So here, factorize it to make it easier for me to see which value of x I'm not going to use. Because when you factorize it, it makes it a lot easier to spot the 0. And that's your two rules that you're just going to continually apply for all of these questions. So for this one, I'd be saying I can't cancel anything out, so there's no square root. All I'm saying is, well, x cannot be equal to 4, and x cannot be equal to 3. Those two numbers in the bottom are going to give me a 0, which means the function is divided by 0, which means it wouldn't work. And it's as simple as that. So you're trying to think on values that break your equations when you're thinking of your domain. Next one. This is a good one, and I picked this deliberately because we've got the square root and the divide. First of all, it's asking us to put g into f. Okay, so where's my f? So f and g into the f. So f is 1 over the square root of, and last time it was 1 over the square root of x, but now it's g of x. I'll put 5 x, okay. And the range for which is undefined. So when would this equation break? Well, it's going to break when the square root of 5 take away x, when that number is equal to 0. We're not going to like that, are we? This whole thing becomes 0, can't divide by 0. The equation is also not going to enjoy when 5 take away x is less than 0, because this number in here would then give you a negative, and that would break. Okay, so that's the two rules you're constantly looking for in there. And then you just rearrange. So 5 take away x, if we square both sides, that's still 0. So 5 is equal to x, so x is equal to 5. So when x is 5, that makes sense, doesn't it? 5 take away 5 gives me 0, square root of 0 is 0, 1 divided by 0, break. This time, 5 is less than x, so x is greater than 5. So when x is greater than 5, let's really think, yeah, if I do 5 take away 6, I'll get negative 1. 5 take away 7, negative 2. Square root I can't do, it breaks. So our final answer there would just to be say, well, when x is greater than or equal to 5, this equation is broken. And that's what it means about the range of values for x, for which that's undefined. Okay. When does your calculator go? This question here. So again with the inverse, we say y is equal to the cube root of x plus 8. So we just rearrange. That's going to be y take away 8 cubed is equal to x, and then we'll just rewrite that. Change this to -1, y to that. Fantastic. So the first mark should be quite straightforward. BODMAS in reverse, like we did in the last video. The next one, state the domain. So this time, you go, oh, domain, what's going on? Well, we were given an original domain. Okay, so for this first one, we were told that if we inputted x, we put in x between 1 and 1,000, we would get our y value out. So if I put an x to this, cube root of x is 1, plus 8 is going to give me 9. If I put in 1,000, cube root of 1,000 is 10, plus 8 is 8. So that means that this inverse has to live between those two numbers. So before, it was x was between 1 and 1,000, but if we're doing the inverse, then like our range becomes the domain, or if you want to think on it like that. So that stays the same, but now 1 becomes 9, that becomes 18. You could have thought about it, backwards as well. This y number here, I could have put that in as the output and then kind of rearrange. Sorry, I could have put in the x in here as my original x. I could have, I think this is the best way of doing it. It's the best way of doing it. thinking about what's going into it. So 1 up to 1,000, and then what's coming out, well, between 9 and 80. So that means that if I was to put in 9 in here, 9 take away 8 is 1, 1 cubed, yeah, we're going back to our 1, 18 take away 8 is 10, 10 cubed takes you back to 1,000. So I could have actually put in the 1 and 1,000 then and work back, but I think that's the easiest way to do it, is to look at your domain, the 1 and the 9, see what that would give you, and that's your new, okay, sorry, that was your original input. That's the kind of simple questions. Slightly trickier ones. Those, okay. Now I really like this question because it's coming back to a few different skills. So it's saying find f of g of x. So let's put in g to f. So I've got 3x plus 5, that's squared, take away 2. All I'm doing is putting this function, the g, into the f. That's nice. And then the other way around. So I'm saying I've got 3x squared, take away 2, plus 5. So instead of f of x, so instead of x, I've got f of x. So here I've got x and x, so I've just substituted that. So you get your first two expressions, and that says the range of values. That's quite an interesting one. You're saying, okay, well, I've got 3x plus 5 squared, take away 2 is less than 3x squared, take away 2 plus 5. Now, what do you think we do here? Well, this is our classic quadratic inequality. We want to break our brackets out, get everything to one side so that it's less than 0, and then we'll sketch the curve. So let's break our brackets out first. Save a wee bit of time there, and then get everything onto one side. So that's going to become 6x squared, as I'm going to move, take away 3 from both sides. I'm just going to rewrite this one here as 23, my like terms together. The 30x, that just stays where it is. Then the 23, so this one again, negative 6 plus 5. Just going to write that as negative 1. So then I'll add 1 to both sides, so that becomes 24. So I've moved everything over, and now we're able to do our sketch. So first thing I want to do is find my roots, and then I can sketch it out. So we're actually going to do roots, sketch. So to find the roots, you always want to put it equal to 0. I'm going to take 6 out, x squared plus 5x plus 4, and factorise it. So when does that become 0? Well, that becomes 0 when x is equal to 4 and 1. Doesn't it add to give you that, multiply to give you that? So on my sketch, I know my roots are going to be 1 and 4. I know it's going to be a happy curve. We've got a positive there, so we have a minimum turning point. Absolutely. The question's saying, when is this function less than 0? Well, it's less than 0 in all these values, isn't it? Because this is my negative zone, and the positive zone's above the x-axis. That's all the positive numbers up here. So absolutely, it's just between the 1 and the 4, isn't it? So x between 4 and 1. Between here and here. That's a really good question. I like that. It's kind of, it's making you think a wee bit. It's put a few things together. So you might see that you should definitely got the first bit, but here, try and spot the minute you see square terms and a less than equal, you're thinking roots and sketch. And I've just realised I've just looked at my final answer there. Sorry, forget that. I should really go back and fix this whole video, but I'm a lazy man. Sorry. Obviously, the roots are -1 and -4, aren't they? I'm rushing. This would become -4, -1, sorry. So it's when x is between -1 and -4. Obviously, eagle-eyed viewers shouting at the screen. I do apologise. It's the chatting and doing the sums that get me. And I'll see if I can get, we've got one, yeah, one last one. How will you do that? Pause the video. Yeah, I'm going to struggle to do this in the remaining 40 odd seconds, so I'll come back to that. But I will do that in one more video at the end, okay? So just skip to the next video. Yeah, just to kind of recap what we've done then. So we've looked at our inverse, which is the standard kind of easier question. We've then looked at the kind of range and domain type questions where when is my equation going to crash? And it's those two rules of can't divide by 0, can't take the square root of a negative, and then slightly more complicated context questions here. So I'll do one more video with this last question.